This video is about sequences and about recognizing different type of sequences. So the simplest type of sequence can be something like, say 3, 5, 7, 9, and so on. Okay, so it seems to go up by 2 every single time. Okay, or we might have a sequence that looks like this: 1, 4, 9, 16. Not as easy, but I can see it seems to go from 3 here, and then 5 here, and 7 here. Okay, so it's a different type of sequence. It changes, but you can still predict what it's going to do next time. You'd probably go 3 times, up by 3, up by 5, up by 7, maybe up by 9 to the next number. Or other sequences again might be like this: 1, 2, 4, 8, 16. So it goes up by 1, goes up by 2, goes up by 4, goes up by 8. And it seems to be doubling. 1 doubles to 2, and so on. So the next one will be 32. Okay. So the way we do these to try to give them the different names, sequences can be linear, they can be quadratic, or they can be exponential. There are other types of sequences, but they're the ones we'll deal with today. So, and what you do is you look at your sequence. We'll say that 3, 5, 7, 9. I'll rub this out to give myself a bit of space. So you look at your 3, 5, 7, 9. Look at this first number, and what you do is you work out what the differences between the sequences are. So this difference is 2, 2, and 2. So there's a difference of 2 all the way along. So the next number you'd guess would be 11. That'd be the next number. The first difference, that's a D, I, F, F, E, or E, N. The first difference is constant. Therefore, that's what these 3 dots mean. Therefore, the sequence is linear. Okay, so we know that the sequence is linear. What about the next sequence I showed you? 1, 4, 7. 1, 4, 9 it was, and then the next number was 16. Okay, let's work out our first difference again. I can see there's 3 here. That's a 9, which is 5 there, and that's a 9. It doesn't look like a 9, but it is. And then 9 to 16 is 7. So that's not going by the same difference every time. Let's try it again. 2 and 2. So the second difference is constant. Therefore, the sequence is quadratic. Is Q-U-A-D, is quadratic. Okay, what's the next term, by the way? What's the next one? So it goes by 3, by 5, by 7. It's going to go to 9, which would be 25, would be the next number. Okay, so that's that one. The last number, the last little sequence I showed you was 1, 2, 4, 8, 16. So let's do this. Work out the first difference between all of these and the second difference and see what that does to us. 1, 2, 4, 8. Okay, there's no constant difference there. Let's do it again. 1, 2, 4. So you see it's repeating here. There's always going to be there's no common first difference, there's no common second difference or constant second difference. This is just repeating over and over. This is an example of an exponential. It's doubling every time. Doubling every time. So what's the next number, by the way? Well, 1 to 2 to 4 to 8 to 16 to 32 would be the next number. Okay, so this is doubling every time. It's called an exponential. Exponential sequence. So there's 3 different types. Now, how do these look, by the way? A linear graph will look like this. If you do a graph, oh goodness, if you do a graph with linear, so a little kind of x and y axis like that, a linear graph is going to look like a straight line, like this. A quadratic graph is going to look like either a U-shaped or an N-shaped quadratic graph. Okay, and an exponential is going to look like this. It's going to get bigger and bigger, exponentially. Okay, so now we've done it. Let's have a look at 3 different questions. I'd like you to identify the sequence type and to identify the next number. So the next number here, what will that number be in each of these sequences? So why don't you pause the video, have a go, and then press play again in a few moments then, and when you've got it done, and check if you've got it right. Okay, well, the answer to this, it seems to be, we put a little, work out what our differences are. That's 4, and 11 to 15 is 4 as well. So we have a constant first difference, therefore this is a linear sequence. And the next number would be 3, 7, 11, 15 would be 19. Let's look at our second sequence. We have 4, 6, 8, 10. So it's not linear. We'll check the second difference. We've got 2, 2, and 2. So the second difference is constant. So therefore it is a quadratic. Quad, or A-T-I-C. It's a quadratic sequence. And the next number, it goes up by 4, by 6, by 8, by 10. Going to go up by 12, I guess. So 42. Let's have a look at this one. That's going up by 4, by 12. Need my calculator for this. I think it's going to be 36. Okay. Okay, and we'll have a look at the next difference. We have 8 and 24. So the first difference isn't constant, the second difference isn't constant, so it's not linear, it's not quadratic. On our course, it has to be an exponential. It's an exponential sequence. So what's the next number? Well, it multiplied by 3. 2 multiplied by 3 is 6. 6 multiplied by 3 is 18. And 3 multiplied by 18 is 54. What's 3 54s? It's 150 and 162. Okay, it's an X number, it's an exponential. Okay, it keeps multiplying by 3. On our course, our exponentials will be either multiplied by 2 or multiplied by 3. They're not going to throw any other numbers in here. So, there we are, the 3 different types of sequences. I hope that helped.